6, problem number 1. As you can see, I've set up the problem with algebra tiles. I have negative 3x here with 13 here, plus 13, equals negative 5x minus 1. I want all my x's to be together. So I'm going to get rid of the negative 3x here. The way I get rid of the negative 3x here is I have to add 3x on this side. And what I do to one side, I have to do to the other. Now you should remember that negative 1 plus 1 is 0. Negative 1x plus 1x is 0. So these are forming 0 pairs. I have 3 0 pairs, so I can just delete those. And on this side, I have negative 1x plus 1x, which is 0. Negative 1x plus 1x is 0. Negative 1x plus 1x, 0. So I am going to remove, not my equal sign, my 3 0 pairs. Now I have my x's on one side. I'm going to get rid of this negative 1 by adding 1 to this side. What I do to one side, I have to do to the other. Negative 1 plus 1 is 0, so these are removed. Now I'm left with negative 2x equals 14. So I separate these into 2 even amounts. So I'm dividing them equally. And now you could see that negative 1x equals 1, 2, 3, 4, 5, 6, 7. But we can't have negative 1x equals 7, because we don't want the negative x. We want just what x equals. So x equals negative 7. That might be unclear to understand why, so I'm just going to show that algebraically. I have negative 3x plus 13 equals negative 5x minus 1. I'm adding 3x to both sides, like we already did earlier with the algebra tiles. Now I have negative 2x minus 1. I'm getting rid of my negative 1, so I add 1 to both sides. I have 14 equals negative 2x. This is what I'm dividing them into 2 piles, but it's negative 2 piles. That's why x equals negative 7, which we weren't really able to see with the algebra tiles. I'll check to see that my solution is correct by substituting. We have negative 3 times negative 7 is positive 21. Negative 5 times negative 7 is positive 35 minus 1. 21 plus 13 is 34. And 35 minus 1 is 34. So it is correct.